Hello student to the web optics course. So today we will going to have lecture number 18 and we will going to continue with the Young's double slit experiment that we have started in the last class. So let me first describe once again the concept of double slit experiment. So we have lecture number 18. So in the Young's double slit experiment, we saw that if we have 2 point source S1 and S2, this separation is D, then the light is coming from S1 and S2, we are going to interfere some point P. So this is Z direction and this is Y direction. Everything say is happening in the YZ plane. Now because of the different path that is propagating by the light S1P and S2P, there is a path difference and that path difference leads to a phase difference and we got an interference pattern, and that interference pattern looks like a cos square function. Like this. This is the direction of theta, and we find that the intensity, which is a function of theta, can be represented by the formula 4 I naught and then cos square pi a, then sin theta divided by lambda. Now for small theta, this expression changes a lot and we get an expression in terms of other parameter cos square pi a divided by lambda and then y by d, where y I measure from here to here. This is my y, and this S to S1 was A, this is D, A, Y and lambda. All the parameters are now known to me. And then we find out the fringe width, that is the separation between these two fringe, delta y was A was lambda multiplied by D divided by A. So if the value of A, lambda and D is given, then one can find out what is the fringe width for this system, this Young's double slit experiment. So this is Young's experiment. Now today what we do, we try to understand that if somebody want to find out the shape of the interference fringes, suppose I bring this source towards A or away from the A, how in XZ plane the fringe pattern will going to change. That we want to study. So, let me draw it once again. So, our goal today to find out the shape of the interference fringe. How the shape of the interference fringe one can determine, that we are going to see. So, let me draw. So, we have two sources and this is the point P, and the coordinate of the point P, say ZY. So, this is the axis y direction and this is Z. So, the coordinate of the P, say ZY. So, if I now shift this dotted line towards this Z axis, I mean over this Z axis, right and left hand side, then what happened, that the fringe pattern will going to change and the shape of the fringe will going to change accordingly. So, we will going to find out what is the equation that describe the shape of the fringe, that is what is the locus of this point P. So, this is the origin, this point I say this is my 0 0 point, that is y equal to 0 and z equal to 0, and this value as usual is A. So, the value, this value is say O, which is the origin. So, the location of S1 in terms of coordinate is 0 A by 2, and the location of the coordinate of this point S2 is 0 minus A by 2. Now, if I calculate simply S1P with all the known values, so S1P square of that is simply Z square plus Y minus A by 2 square. Similarly, S2P square is Z square plus Y plus A by 2 square, these two. Now, the part difference if I calculate, that comes out to be delta equal to S2P minus S1P. So, from here I can have an equation in terms of delta between S1P and S2P, and that is delta plus S1P and square of that is essentially S2P square of this. So, we have delta square, then S1P square, I can find it from here because this value is known, is plus Z square plus Y minus A by 2 square, and there is a 2AB term. So, I should write plus 2A and B will be the root over of that thing, and that is root over of Z square plus y minus a by 2 square. That thing should be equivalent to z square plus y plus a by 2 square of it. Now there are several terms that should be cancelled out. For example, here z square will cancel out, y square will be cancelled out, a by 2 square term will be there, a by 2 square term will be there, so that will be cancelled out. So removing all this term, we are going to get 2 delta then this term root over of z square plus y minus a by 2 whole square is equal to 2 of ay, that term will remain here, and minus of delta square. Okay, or we can divide this here. So z square plus y minus a by 2 whole square whole to the power half is equal to ay by delta plus minus delta by 2. Minus delta by 2. So if I square both side, then we are going to get z square plus y minus a by 2 square of that is equal to ya divided by delta minus delta by 2 square. So here we have z square plus y square minus ya plus a square by 4, that is equal to y square a square by delta square minus ya, 2ab term becomes ya, and then plus delta square divided by 4. So y term will cancel out. So essentially we have z square and then minus y square. If I take common, then it should be a square by delta square minus 1, and in other side we have the delta terms. I am keeping all the z and y term one side, and it should be 1 by 4 and then delta square minus a square. So I can rearrange these things and I can have an expression like y square divided by delta square by 4 minus z square divided by a square minus delta square whole divided by 4 is equal to 1. Just dividing everything and rearranging, we can simply get this. So, this is a equation in YZ plane, how the point P, if I shift the point P, how the point P will going to behave, or what is the locus of this point P when A is fixed and delta is the corresponding path difference. So, this is essentially the equation of the hyperbola. In YZ plane. This is equation of the hyperbola in YZ plane. So, for fixed path difference delta, if I now want to see how this plot will be, so I will need to go to next. So, let me write down the expression once again. This is y square divided by delta square by 4 minus z square divided by a square minus delta square divided by 4 is 1. So, if delta, for a fixed delta, that is path difference, we shift the point P in such a way the path difference is fixed. So, for a fixed delta, that is path difference, one can have so this is my Z and the point S1 and S2 is here, and if I draw this, so I can have the point P which is over this line. So, this line will be something like this. This is hyperbola, so it goes like this. Then it goes like this. So, we know that when an expression is given by this, then the eccentricity of the system is given by this 1 plus q square divided by p square. So, for this hyperbola, the eccentricity is given by this. In this case, if I compare this equation to this equation, then my E comes out to be root over of delta square by 4 plus a square minus delta square divided by 4 into, just replacing these things and simplifying, into 1 divided by delta by 2. So, that means it is 4 delta square. So, I can simplify it further. It is simply A divided by delta. So, generally the order of delta is 10 to the power of minus 8 centimeter. That is the path difference we are talking about. And the order of A is of the order of 10 to the power of minus 2 centimeter, which is the separation between these source. So, if I put this value, we can see that E is very high. And when the eccentricity is very high, it almost behaves like a straight line for large distance, and we get in the figure also in this way. So, that means if I move over this, if I move my my screen. So, this is, so in general there is this screen is present here, and if P is over the screen and if I get a maxima here, if I move this screen, the points that is here, this straight line over which all the P points, then this maxima will be there only, and that maxima corresponds to the same path difference that is generating. So, we will going to get an expression of hyperbola for the shape of these fringes. So, that is the way one can calculate by simply do whatever the geometry they have. Okay. After that, we quickly discuss two more system, couple of system where one can also find out the interference pattern, and this interference pattern are generated due to the virtual sources. Here in two slit experiment, we have two sources which are real sources, but it is possible that even without having any real source, due to the virtual source, we can generate the interference pattern. Two cases we are going to discuss quickly. So, first, so let me write down. So, this is interference with virtual source. Interference with virtual source. So, the example 1 is called the Lloyd mirror. So, what is the Lloyd mirror? What is the setup? So, the setup, you need to understand this setup and then rest of the things you understand quickly. So, the setup is, I have a source here S and a finite mirror somewhere here. So, one light can directly fall here over this mirror, and it reflects. So, this is suppose my screen where I want to find out. Okay, my drawing is bad, so I need to change it. And if I extend this, so here we can have my virtual source, which is S prime. Now, from here to here, the length is A. So, it reaches here, and one ray one can, it is going directly here. So this is ray 1 and one ray is going from here and bounce back, and another ray from this side is also going to here at this point, and it is also coming out from this virtual point. So that is the setup. So this is ray 1 that is coming here, and this is ray 2 coming here. One ray is going directly and another is going like this. So you can see that there is a region where the direct ray and the ray that is coming from this virtual source will going to interfere. So if this length, this is d, it is exactly like a double slit experiment. If I understand properly, then this is one source S1 and this is S2. Instead of S1 I write S, which is a real source, and this is a virtual source. The interference is happening because of the interference due to the light that is coming from the real source, and it is a reflected light that is coming from the virtual source. So the interference pattern should form somewhere here like this. So this is the region where one can expect the interference pattern, the fringes having bright and dark patches. So the fringe width, if somebody want to calculate, because it is equivalent to the double slit kind of experiment, the fringe width one can calculate, and the value will be like beta is equal to lambda d divided by A. So the A is basically the separation between these virtual sources. So if you know what is the value of S, this length, if you know, so this is L, then A is nothing but 2 of L, the perpendicular distance from the mirror to. So this is the mirror, say M1, and over this mirror the ray is falling and they will going to interfere here in this region, the direct ray. So this is the schematic diagram of Lloyd's mirror. Another example quickly I will try to make whatever the time we have, and that is called the Fresnel's biprism. In Fresnel's biprism, we have a plane here where we have a source sitting here. This is the real source. But we have a prism with very small angle is there. This is the biprism. Now what happened? The light from the S will come like this. It will go here and then show you the path of the light, but it goes like this. I have another light, and that will reflect like this. And suppose we have a screen here. So one light also will come here, goes like here, and then come this direction. Another light will also go here, move here, and diffract. So when I extend these two, so they will form a virtual source here at this point. And similarly at this point. So this is S1, which is a virtual source, and S2, which is a virtual source. And because of the light coming from S1 and S2, there will be interference pattern one can observe. So interference pattern will be observed in this region in this way. So this is the interference pattern one can observe here, and this will be along y direction. If I go to maxima, so this is the mth order maxima. Well, if I have this angle alpha, then we know, and this is the minimum deviation delta m. So we can have a relation that delta m will be alpha into refractive index of the prism minus 1, that we know from the geometry. And if this is a by 2 and this separation from the prism to this virtual source is d, and this separation, if it is d, then this delta m for virtual source separation can be approximated as delta m is nearly equal to a by 2 divided by small d for small angle, for small delta m. Now from here I can find out a is equal to 2 of d delta m, or 2 of d alpha n minus 1, because delta m is n minus 1. So this is my a value, which is a separation between these two sources S1 and S2. Once you know this, then the maxima point can be simply calculated as m lambda, and d here will be simply replaced by d plus small d, the same equation that we are using, that we have used for double slit problem, divided by a, which is 2d alpha n minus 1. So we have the formula for the length for mth order maxima, and that is defined by this. So using this biprism, one can generate this kind of fringe, and from the fringe, by calculating the fringe width or the location of the fringe, one can also calculate the lambda once the d, small d value and the angle of prism is known, and the refractive index of also unknown. So unknown lambda can be figured out. So this is such experiment that is done in the laboratory, in the optics laboratory, where using this technique, basically the fringe width are calculated, and also from the fringe width one can calculate the unknown wavelength as well. So this is an interesting kind of experiment that you may encounter in your course, and the structure of this experiment is schematically shown here, which is nothing but like a double slit experiment, but here instead of having one source we have two sources, but they are situated in a virtual position S1 and S2. So, I am not going to discuss much because we do not have much time today. So, today what we did is we try to understand that if the light is interacting in double slit experiment, then the fringes are formed, and once the fringes are formed, how the shape of the fringe will going to change. So, we find that it is like a hyperbola, the pattern will be like a hyperbola. Also, we understand that if we put some proper arrangement, then there is a possibility that I can split this wavefront, and these two splitted wavefront can interfere to each other and can form a fringe. Two examples are given. One is the Lloyd's mirror experiment, where using a mirror you figure out, you put a source, and then this source will give you a reflection, and as if the reflected ray is coming from this virtual source, that is the virtual image that is formed by the mirror, and we are going to get a interference pattern. Similarly, we can split the wavefront here by using by prism. The figure is there already in front of you, and where the light is splitted through this prism, and two virtual sources are generated, and from these two virtual sources the light is coming, and they are interfering each other and form the interference pattern. And from this interference pattern one can calculate many things. One of the important thing is wavelength. So, that is for today. So, we are not going to discuss much about this phenomena. In the next class, what we do, that we are going to discuss about how instead of splitting the wavefront, if I just split the amplitude, then these two splitted amplitude can also interfere to each other and can form the interference pattern. Several nice examples are there, like Newton's ring and then Michelson interferometer, etc. So, that we are going to discuss in the future classes. So, thank you for your attention and see you in the next class for more. Thank you.